When we're looking at the hydrogen atom, we just want to understand a couple of things about the structure of the hydrogen atom and how we can use light to study its structure. When we have an electron, just a single electron in a hydrogen atom in the lowest energy level, that electron can jump up and down between different energy levels as it absorbs and gives off light. So a couple of the key features. Number one, absorbing will make the electron jump up to a higher energy. So a photon of light comes in, it's a single light particle. It could hit that electron and cause it to jump up to another level. So it is absorbed energy. This distance here, this gap, is an energy change. That energy change correlates with this photon. So what we want to understand is, there were two equations we're going to work with. The one of them is not really important. It just kind of helps us bridge the gap to the one we do want. One of them tells us how do we calculate this energy jump using the Rydberg equation. And that was this strange one. And we're actually not going to use this equation in AP, but this is for the purpose of the lab. This helped us calculate the change in energy, the jump between these. We actually need that so we can get to the other one that we do want, which is how energy is related to that wavelength of light. Because this energy jump is going to tell us what kind of light will make that jump, will cause the electron to make that jump. So we get the change in energy is hc over lambda. This is Planck's constant, and the speed of light will give us the wavelength. The other thing we want to see is when the electron comes down, returns back to the ground state, which is closer to the nucleus, it's going to go through that same energy jump, except now it's going to be exothermic, or give off light though in this case. Its light is going to be released. So the energy change is going to be negative, and we will get out of that a photon coming away. So it can give off light. And it'll be the same light that it absorbed during that jump, because there's only one wavelength of light that goes with that energy. If the electron wanted to jump from 1 to 3, there's only one wavelength of light that goes with that energy gap to make it happen. That is a bigger energy jump. So that's going to require more energetic light. So we're going to have that conversation. When it jumps back down, it can give off that same photon of light. Or if you were paying careful attention, it could actually jump and stop here in the middle and give off light that corresponds to this energy gap, and then jump from 2 to 1 and come back down. So it can actually give off two different photons and divide that energy up. There's different ways that can do that. This helps us explain how the electron's actually not allowed to just jump anywhere in the middle of the atom. It can be here or here, but not in the middle. And it gives off light corresponding to very specific jumps. So there are only certain wavelengths that light can emit. Each one goes with a certain energy jump. And it's giving off light when they jump down. It's absorbing light when they go up. So we have to understand the absorption and the emission parts of how light interacts with that electron. So we want to understand that these energy levels exist in the atom. This is kind of our Bohr model, but in just a y-axis scale. That these energy jumps, the distance between them, represent energies, and each one of those energy jumps, and it can be from 1 to 3, it can be from 3 to 4. There's a lot of different energy jumps we can put in here, more than just what I've labeled. Each one of these energy jumps corresponds with a certain frequency and wavelength of light that we can measure. And you also want to see, the last thing is that as the atom gets bigger and bigger and you get more and more shells and energy levels, that you can see that the shells actually get closer and closer together. And it's a big jump to go from 1 to 2, but it's just a little energy to go from 4 to 5. So that tells us a little bit about what kind of light can make those jumps. And that's how we look at the emission spectrum for a hydrogen atom and how electrons jump around. And this is primarily the equation that we want to get out of it. Even though we used the other one, we needed it for the lab. This is the one that's the more important one, how these energy jumps correspond with wavelengths of light.